So today we're going to kind of start looking at some ways that we can think differently about numbers, how they can work together. So I want you to take a moment to think about this problem, and once you think you might have come up with two ways or you're stuck and can only come up with one, then I want you to go ahead and hit play and see how you could actually do this problem both ways. Okay, so this problem says, what is the area of each rectangle? Then what is the area of both together? And can you prove the total area two ways? So we should know we find area by doing length times width. So for the first rectangle, we're going to do 5 times 13, which is 65. And really, it would be 65 square feet. For what we're doing, we're not so much concerned about the units, but please do take note of that. For the second one, we would do 4 times 5, which would give us 20 square feet. So there are our two areas, and if we wanted to find the total, remember again, we found that by doing 5 times 13 and also doing 5 times 4, and that gave us 65 and 20. And if we want to find the total area, then all we need to do is add those, and we're going to get 85. So that's definitely one way we can do this problem. But there's another way. Think about this. If we wanted to, we could put those two rectangles right beside each other, just like that, since their 5-foot sides are both exactly the same. They are congruent. Therefore, we could put them end to end like that, and we could actually think of this, instead of thinking of it as two separate rectangles, think of it as one big rectangle, and the big rectangle is 5 feet by these two sides together, which are 13 and 4. So we really could look at this as 5 times the sum of 13 and 4. Remember, when you have a number next to parentheses with nothing in between, that means multiply, even when the symbol's not there. So if we solved that one, notice that we would get 17 for 13 plus 4, and then 5 times 17 is 85. So we get the same answer either way. Now, the point of this is understanding that these two statements at the top are equal to each other. And also understanding that if we wanted to, we could simplify the 5 times the sum of 13 and 4 to equal 65 plus 20. All right, moving along, let's look at another problem. Try this one, and you may want some graph paper to try it. Try it, see what you think, see if you can come up with two ways to find the area. Okay, so now that you've had a chance to look at it, let's see what you came up with if you were able to draw the picture. Now think about this. It says 2 lab tables are each 4 feet wide. One is 7 feet long, another is 5 feet long. What is the total area if the two tables are placed end to end? Draw and label a diagram to illustrate the situation, then give at least two ways to find the total area. Thinking about this, hopefully you can see that this is a little bit like if you go to a restaurant and the table's not big enough. A lot of times they'll put two tables together. So it's that same kind of situation. The first table is 4 feet by 7 feet, because one table is both tables are 4 feet wide. One is 7 feet long. 1, 2, 3, 4, 5, 6, 7. And so there's the first table, 4 by 7. And then the second table is 4 by 5. They're placed end to end. Oops, that's 4 by 4. We need 4 by 5. So 4 by 5 looks like this. Now, if we wanted to find the area, we could do it two ways. We could look at the two tables separately, which if we did, we would do 4 times 7 plus 4 times 5. And we would figure out that that makes 28 plus 20. So 28, this one is 28, and this one is 20. And then we could get a total area of 48. The other way we could do that, though, is we could say, well, we know that the whole big thing together would be 4 times 7 and 5 pushed together. So that is really 4 times 12, which is also 48. So either way, we're going to get 48 as our answer. Let's look at one more example, one more visual example. The marching bands from Cox Mill and Northwest are performing together. Both groups will march in rows of 6. Cox Mills Band will be 9 rows long, and Northwest's band will be 4 rows long. How many band members are there altogether? Draw and label a diagram to illustrate the situation, then show at least 2 ways to find the total number of band members. So pause, and when you're done thinking about it, hit play. All right, now that you've had a little bit of time to think about it, hopefully you've drawn something that looks like this. Think about our marching bands going this way. So if they're going that way, it says they're in rows of 6, so that's 1, 2, 3, 4, 5, 6 people. And you could even, if it makes you happy, you can think of it. Here's our marchers. 6 across in a row. They're marching forward. So there's 6 people in each row marching forward. And then the Cox Mill Band is 9 rows long. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is Cox Mill. And then Northwest is going to be behind them. And they have also 6 members in each row, but there's only 4 rows of them. So here's our Northwest people. So they are also 6, but again, only 4 rows. So if we look at them then, we could say, well, the Northwest people are going to be 4 rows of 6, so that's going to be 24 people. And then the Cox Mill people are going to be 9 rows of 6, which is going to be 54 people. Again, the way that I got that is by doing, for Cox Mill, I did 6 times 9. And for Northwest, I did 6 times 4. And so that gave me 54 people plus 24 people, which if I worked it out gives me 78. Notice, though, I get the same thing if instead of thinking them as separate groups, I just put them together and say, well, there are 6 rows, or there are 6 people in a row, rather, and there are 9 plus 4. 9 Cox Mill rows and 4 Northwest rows. So altogether, that's 13 rows, and 6 times 13 is 78. Now I want to transition into looking at just the diagrams without it necessarily being in the context of a word problem and seeing if we can find missing numbers, if we can figure out what this is trying to say or how we could apply this. So using our area models, if we have some missing numbers, we've got a missing number here and here. This number, this first one, has to be, see if you think you know what it is, and when you think you know, hit play and see if you're right. So this first number has to be 28 because the first piece is 7 by 4. This number up here has to be 11 because 77 divided by 11, or divided by 7 rather, is 11. Or in other words, 7 times 11 is 77. So what this one is showing is it's showing that I could look at this as 7 times the sum of 4 and 11, but that also equals 28 plus 77. Try the next one and see what you get for that one. Okay, for this one, since this distance is 9 and the total area of that first box is 27, that means that the missing side length has to be 2. 27 divided, or 3 rather. 27 divided by 9 is 3. Well, now that I know that this missing side length is 3, then so is this one. And 3 times 5 is 15. That's our missing area. So what this is saying is I could look at 3 times the sum of 9 and 5, and that would equal 27 plus 15. Now take a look at these two expressions and see if you know how you could draw a diagram of those or an area model of those. And then once you have your area model, can you get what sum comes from that? Give both of these a try and then see if you're right. So for the first one, what it's really saying is I have one side that is 2, and then I have 2 sections. One section is 5, and the other one is 9. So this is what I should set up for my area model, and that's going to give me 10 and 18 as my 2 inside numbers, my 2 areas. So that means 2 times the sum of 5 and 9 is really equal to 10 plus 18. For the second one, Now that one looks a little different because the 6 is at the end. It's on the outside at the end, but it still really means the same thing. So when I draw my area model for this one, my number that I'm multiplying by, one side is 6, and the other side of my figure is 4 plus 7. So that means it's two sections. The first one is 4 and the second one is 7. So when I do 6 times the sum of 4 and 7, I'm really going to get 24 plus 42. So I could simplify this to say 24 plus 42. And that should give you a pretty good background going into looking at distributive property.